we're going to do section 9.1, page 445, number 35, which reads, determine the convergence or divergence of the sequence with given nth term. If the sequence converges, find its limit. And for number 35, an is equal to -1 to the n times n minus 1 over n plus 3. Now, we've talked several times about how determining if a sequence converges or diverges involves finding its limit as n goes to infinity. And this is because if that limit is equal to a finite number, then we're going to say that the sequence converges. But if that limit for the nth term is undefined or is equal to infinity, then we're going to have to say that that sequence diverges. So we're going to have to find the limit as n goes to infinity of an, which is going to be equal to the limit as n goes to infinity of -1 to the n times n minus 1 over n plus 3. Now, we've also talked about and reminded ourselves about several methods that we have for evaluating limits. Now, the first one is to graph. You've learned several times in this section how to graph a sequence, and in this case you're actually going to need to use that information and graph this as a sequence, not as a regular function. And if you do that, and again, if you have trouble with this, you should come and see me and we can go through it together. When I graph this, I get something that looks like this. To me, that looks like a sequence that's going to diverge. I don't really see it honing in on a single number. It looks like the values keep growing and getting bigger and bigger and bigger. But we need to look at some other methods and confirm our suspicion. So the second method was to substitute in, which means that everywhere that we see an n, we substitute in n's limit, which in this case is infinity. And again, that's not really going to help us either. Our third method was to do some algebra or do some simplification. Again, this nth term doesn't really lend itself to that. So what was our last way of trying to evaluate a limit? Well, it was end behavior modeling. And in end behavior modeling, we say that a polynomial, when we look at very, very, very large values of n in this case, will act like the term with the highest exponent. So we've got our limit here. The limit as n goes to infinity of -1 to the n times n minus 1 over n plus 3. And we do have two polynomials, n minus 1 and n plus 3. And each of them is going to behave like n, because that is the term with the highest order in each polynomial. So we're going to have the limit as n goes to infinity of -1 to the n times n over n. And now we can go back and do a little simplification, because that n over n is going to cancel, and we're going to end up with the limit as n goes to infinity of -1 to the n, and that is going to diverge. That is going to alternate back and forth between 1 and -1, and it's never going to approach a single value. So this is a sequence that diverges, as we suspected when we looked at the graph.